And first off, we are going to hear about the DRATS analog mission. Take it away, Barbara.
Okay, thanks, Kelsey. First, can I confirm that you can hear and see me?
Loud and clear.
Okay, great. So yes, as Kelsey said, my name is Barbara Janoiko. I'm one of the mission managers for Desert Research and Technology Studies, for which I'm going to give you an update today. Next slide, please. So last year we conducted what we call Desert RATS Light. Our sponsor was the HEO SCNI Strategy and Architectures team that wanted us to focus on looking at lighting and navigation capabilities in an analog field environment so that we could continue to conduct this type of analog test moving into the future. And so last year we went to the SP crater area in the San Francisco volcanic field north of Flagstaff, Arizona. We were out there for about a week in October. And for those of you that aren't aware of, previous Desert RATS testing had been conducted for 14 years from 1997 until 2011. And so last year it had been a decade since we had last been out to the desert. And so we really needed to redevelop and in most cases of the team members develop the capabilities and skills needed to continue to conduct this type of testing. We also had a new mode of operations since we're going to the lunar South Pole now that necessitated simulating a low natural lighting conditions at night. And so we really focused on looking at capabilities last year. And primarily we established the communications between the field and a flight control team back in Houston. We also had some remote observers that were on the line supporting the test and simulated not only the low-angled natural lighting conditions, but also some artificial lighting conditions that would be part of Artemis testing. And then we conducted, to evaluate the capabilities, we conducted 4 representative early Artemis surface EVAs to evaluate the capabilities, but also start to understand some of the operations challenges associated with conducting EVAs in these conditions. Next slide, please. So this year we have the same strategy and architectures customer. We are planning to go to the Black Point lava flow, which is about 10 miles northeast of the SP crater area where we tested last year. Our customer wants us to focus more on pressurized rover operations this year, though. So we'll be looking at how to best use the pressurized rover for exploration. And to do that, we'll be conducting some 2-day, day-in-the-life activities that will include not only IVA tasks inside the rover, but also shirt-sleeve science EVA tasks, as well as overnight stays within the rover. And we are integrating JAXA engineers and astronauts as part of the team and including some of their design elements into the testing, such as looking at different window configurations and different drive crab angles for the rover itself, as well as some interior ECLS type hardware that they are considering in their design. And then thirdly, we're looking at a flight control team that also includes a science evaluation room and trying to understand how the flight control team can best monitor and support EVAs. And that team will be located in Houston. And so all of these objectives not only support the pre-formulation team and development for the pressurized rover, but also JAXA is planning to have a pressurized rover system requirements review sometime next year. And so everything we learned this year is going to feed forward into the requirements that go into that SRR. And you can see from the schedule there on the slide, we're about to get into a operations products development phase, and we have some testing at the rock yard at JSC planned in September, and then the field test itself in the September-October timeframe. Next slide, please. And just a little bit on the hardware itself that we'll be testing. So we are bringing out the pressurized rover cabin 1B that had previously been tested at other Desert RATS tests. It has 1 side hatch, 2 suit ports, and an environmental shelter or cabana that would protect the suits if they were attached to the suit ports. We're planning to use a NASA astronaut and JAXA astronaut or engineer as part of the 2-person rover crew for the day-in-the-life testing. And when they go EVA, they'll be wearing shirt sleeve backpacks that have a camera and lights attached. They'll be using tools. Some of the tools that Adam talked about earlier would be mounted on the back of the rover, as well as we'll be looking at this walking stick tool carrier concept for carrying around with the crew as they go on their excursion away from the rover. And we'll be using a portable sun to simulate the low angle lighting condition. And that's all I have. Thank you.
Thanks so much, Barbara. And we will take questions in the Q&A period.